Okay, good evening, everyone.
Hi, Latif.
Hi, how's everyone? I'm Sweli and the other participants. So we kick off day 2. Hopefully we get to cover the deliverables. Hi, Prof. Osana.
Hi, Dr. Latif. Good to see you.
Yeah, I have to check on my boss. Yeah. Okay, let's get started. Today we'll be making use of Today we'll be making use of the offline Jupyter notebook. So I'm perfectly sure that everyone has installed the Jupyter notebook. So let me share my screen. So if you have this Anaconda navigator, so this is where you launch the Jupyter notebook. That's if you are using the Anaconda navigator. So if you follow through the tutorial we sent, that document, and you were able to install Anaconda, this is where it will take you, and you'll be able to launch the Jupyter notebook. But because I've already launched mine, so I'll just close this. So let me just go straight to sharing my Jupyter notebook. Okay. Okay, so this is what I expect from you, because I've got a couple of other notebooks here, but I'll be opening a new one. So I'll open a new notebook, Python 3. So today, if there are questions, unlike yesterday, if there are questions, please pile them up so we answer them at once after this session, okay? Otherwise, if you can chat Sibukele, if you can chat her, then yeah, she can quickly respond. Otherwise, we'd have to pile them up till the session ends. Is that fine by you?
Yeah, it's fine.
Okay. So yesterday, you'd recall, because we were using the cloud version, the Google Colab, and you recall that we had to store our data in our Google Drive. But today we are trying to do a similar approach, but quite different in terms of storage. So what I will do now is take note of where your data was, where your Jupyter was installed. For example, if you look at this, you'd see that all my files are here. So how do I locate it on my computer? So just come here and say import OS. So OS is a library in Python that allows us to work with direct file directories. So let me run that. So then if that runs successfully and you say OS dot, remember yesterday we said the library name, the library has its own modules. So this dot references those elements that are in the library. So dot gets CWD. So that's the function, get CWD. So it retrieves the working directory where we can store our files. So let's see for here. So now it's saying my files are in my local disk C/user/HP. So that's where I can find this file. So I can do that. I mean, if you do that on your own computer, it will probably be a different directory. Yours could be D, yours could be somewhere else. So try and check which one is yours. But if you want to change the folder, as I'll be doing right now, so for example, on my own computer, I usually store this kind of files in a folder called nemisa datathon. So I'm going to change the directory to os dot. Now the function is change directory, chdir. So you open double quote or a single quote. So let's say C. Now this is a backslash, not a front slash. Users HP. That's where yours could be different. It depends on the location where you want to store your data. So one slash desktop, somewhere on my desktop. I have a folder called Profile Sign-up. So anything that has to do with Profile, it's in that folder. How do I spell that? Okay, I think I usually spell / Python masterclass. Yeah, I think that's it. So let me run this to confirm. Okay, let me see what's wrong. Okay, what I'll do is this. Let me go to the directory itself to copy the link. So I have to share my screen so you see my directory. Yeah, this is the directory. So I'll just come here, right click to get the actual link. So this is it. So let me copy it. So this is another way for accuracy. Copy. Okay, then let me share the Jupyter notebook. Okay, so that's just what I'm going to copy and paste here now. Yeah, so that's it. It wants me to use double slash simply because if you look at the os.get.cwd, it returned double slash. So let's see. Yeah, so all is well now. So if I type get cwd now in a new cell, I'm going to get this directory. Can you see it? So let me know if you got that. How did we get to Jupyter Notebook? I showed that when I started. Like I showed you the Anaconda Navigator. Maybe I should show it again. Let me see. Yeah, this is it for that person asking the question. Look at it. This is where you get to Jupyter Notebook. Just click on launch. Okay. So let me go back to the Jupyter Notebook. Okay, so are we good to go on that?
Yes.
Okay, good.
But
so now we have our directory. All of you have your directories where you stored your data. So now, particularly that organics 2018 data has to be there. You have to store it in this folder. Okay, get your own directory and make sure that your data is sitting somewhere in your in that folder. So I have I have that in my phone.
Hi.
Yeah. Hi.
How are you?
I'm good.
I'm good. I'm having a problem with I did get my CWD, but then when I did OS dot CHDR and put inside the directory, it's giving me an error.
Yeah. So what you do is, for accuracy's sake, first of all, ensure, because this thing's vary by computer. For example, this number one error that is possible is your slash. It's possible you use the front slash instead of a backslash. That's number one. Number two, it's also possible that you use a single slash instead of double slash. So for your own computer, you have to be sure what the exact format is. So make sure you type this os.getcwd. Try and see the format. Is it double slash, or is it front slash or backslash? So use that same format when you want to use your change directory. So for example, in your own case.
Okay.
Yeah,
I think I managed to fix it, and it's running now.
Oh, perfect. Perfect. So let's get back to importing our data. Our DATs, what we call DATs yesterday. So we said, but first, let's import our libraries. Import pandas, don't forget, pandas as PD. Import NumPy as NP. I think these are the two basic libraries we'll be needing for now. Okay, import matplotlib.pyplot as PT. So let's make use of this for now. If I need any other one, I'll let you know. Okay, so I'll then say that equals read, PD dot. The function now is read underscore Excel, because the file organics 2018 is an Excel file. So read underscore Excel, open double quotes. So the name of the file is organics 2018.xlsx. Okay, that's from yesterday, if you remember. So just to be sure that that was successful, so I open a new cell to say dat.edge. Let's just see the data. Okay, so that's successful. We have the data imported. So I hope you get to that stage also. Okay. Now, to continue where we stopped from yesterday, to show you how to modify columns and rows. To subset variables or subset rows from your data. Subset some variables from this entire data. Like, I don't need every one of them. I just need a few variables from here. Use the LOC function. So that will be dat.loc. Now, there are two versions of this. There's the LOC and there's the ILOC. I'll show you the difference. Make use of the column names, okay? While ILOC allows you to make use of their integer values. You see the difference now. So now, because this is a data frame is usually rows and columns. So separated by a comma. So you have a comma separating the row from the column. So whatever is on the left is indexing the rows, and whatever is on the right is indexing the column. So this comma is separating them. I'm interested in selecting all the rows. So I'll just use this colon sign and colon symbol. So it tells Python to extract all the rows, but I want to extract a few columns. So you open a new square bracket and you type the labels, which variables I want to extract. So let's say I just want to extract gender and age, just two. Like I just want to work with these two variables. So again, I repeat, what's on the left is the rows, what's on the right is the column. So that's why colon is here is to refer, I mean, it refers to all the rows, okay? But if I want specific rows, which I will show you just now, but let me run this for you to see. So you can see I've succeeded in extracting just two columns, but I retained all the rows. So, but let's say I'm interested in, let me go to the next cell. So let's say I'm interested in again, I'm extracting gender and age. I'm extracting gender and age, but this time around, I only want rows, okay? Or the first four rows, whatever. But mind you, Python starts its own counting from 0, not 1. So that's 0 to, let's say, 3. So that means it's not going to return all the rows, okay? So this has to be inside square brackets for referencing, okay? So you can see from here, it has only returned 0, 1, 2, 3, okay? First row, second row, third row, fourth row. So that's how to subset from a data frame. You just want to make use of the entire. So like I said, you can do this in two ways. Another way is to make use of the ILOC function. What that does is that you don't have to use the actual names of the columns. You can use their location, the number. So for example, gender, and it can tell you the corresponding number. For example, so I'm returning all the rows, but I want to return 0 to 2. So let's see what happens in that case. I'm using iLook, and let's see what happens. So you can see what has it done. So that's it, the first two, because Python starts is counting from 0. Okay, so that's why it's returning first two now, customer ID and gender. So that's the first two. Okay, customer ID and gender. And you could go on and on. I could go 0 to 5. Okay, and that's what I want to retain. So that's it. Any question on that? Before I move on to the next topic.
Sir, can you please share the data set with us? Because when we try to read it, I don't have the data set.
Oh, were you not here yesterday?
No.
Oh, okay.
The link for the data set is shared in the chat. He's using the organics data set, the Excel file.
The file that I got from the chat, it's the Penta one.
No, ignore the cancer. Ignore the cancer one.
There is a chat like twice today. It has been shared. Organics download link. It's an Organics 2018 Excel file. I've shared it and someone else has shared it. Like it has been shared twice in the chat.
I can resend it if you want.
I'm sharing it again.
Okay.
Okay. I got it.
The
Great.
Excel file.
Yes, I did get the file. I downloaded it.
Okay, good. So now, one last thing on data manipulation. One last thing I want to show you before we go to plots is let's look at this gender variable, because this is common in real life. Like, okay, you've done a survey and you've got responses from your respondents, and they are returning answers that do not make sense. Okay, how do you deal with them? For example, if you look at gender, you can only be male or female. So what's this you? What does it mean? That's undecided, or someone prefer not to disclose their gender. Is that not the possibility? So because of that, it only makes sense to deal with this you. Okay. So what you could do is turn this you to a missing value. Okay. So, and that's what I want to illustrate, to say, okay, what if you are in this kind of situation where you have responses that do not make sense and you want to deal with them? So I would go to the next cell and say, okay, I want to work with variable gender. And say gender equals to you, replace it to a missing value. Now in Python, like I said yesterday, recognizes missing values with some keywords like NaN, null, like this, or NaN. I think NaN like this, or capital letter NaN, something like this. So in this case, we'll be making the NumPy.
Can I stop you shortly, Latif?
Okay.
I think the biggest issue that is there is that they are not, they can see the file, they've downloaded the file. What they're not able to do is read the file. So that read Excel section is what they need. I think also, yeah, that's where I think they're stuck from what I'm getting on the chats. Now, I don't know if it's this exact line or the fact of or the fact of trying to load that file onto Jupyter, because the other way is to use the home screen and just upload this file into Jupyter so that they don't have to write the long link. Is that not an option? Because I think that's the issue there. They are not able to read the file. So they're kind of stuck here.
Is it everyone? Because it's strange, because if you don't get it right now, I don't know. Let me see. Did you type this exact same code? Whoever asked that question, did you type this exact same code? Okay, I know what the problem could be. It's possible you did not store that file in that particular directory. Like, look at this directory and ensure that, for example, this my data is in this folder, Python masterclass, under Profosana, under my desktop. So you should also ensure that your file is sitting somewhere in this your folder. Otherwise, it will not install. That's my best guess. So let me see the question. Let's say it says also the file has to be in the same folder with the notebook. I don't know if this is a question. Because otherwise you will not be able to install it. I mean, you will not be able to import rather. Okay. So let me know if you still have that challenge.
Guys, are you fine now or you still have the challenge?
I'm okay this side.
Sorry, the person who said is okay right now, can you tell us where you stored your file?
I stored my file in the nemisa masterclass. I created a folder for those two files.
Okay, you also have a folder on your desktop, right?
Yes.
Okay, so that's the same thing everyone should do. You should have a folder where you kept the file, so that you then right click to go and copy the link. Maybe I should show you the process. Maybe I should show the process again. This is my folder. I'm not sure you can see my screen. This is my folder now. Can everyone see the screen?
Yes.
Yes.
Okay. look at the path from desktop to Profosana, from Profosana to Python Masterclass. That's my folder. So now this is the file I'm working with. So for you to get the actual path, you need to copy, right click, go to properties and copy the link in the, look at the location. Copy the link. Okay, copy the link. I copied it. Then once you've copied it, you are good to go. Okay, let me go back to the Jupyter. So once you copy the link, that's what you will paste inside these single quotes like this. Let me do that again. Can you see it? So, but in my own case, it's making use of double slash, not a single slash. So I had to change this single slash to double slash. In your own computer, it could be a single slash. I've experienced that before. So it's not as if it will always be double slash. So that's why I said, be sure of by first typing this get CWD so that you know which format it's using. Because I already know it's using double slash, then I had to change this to double slash. That's all. If you do this, then there's no way you'd not be able to import it. I can assure you. Okay. So I'm going to move on. Let me check the chat box. I did this. Yes.
The chat is clear.
I just needed the line of code. Okay, now you've got the line of code. Good.
Sir.
Okay, fantastic. So from NumPy, I want to import NaN. Like I said, NaN is for missing value. Now, I'm going to reference my dat. Okay. Dots, like I said, LOC is for I open this square bracket. Square brackets are usually used for referencing lists or data frames. That's the name of the data. So inside that, like I said, inside that now, I'm interested in gender. So again, I open another square bracket because square brackets, like I said, is used to reference something inside a data frame. So what is in gender? So I'm working with gender. I'm saying whenever gender equals now is this, not this one. This one is for assignment, while this is actual equality. Equals, so when it's double, that's equal. And don't forget, what are we working on? We are working on this value, u. We said this u is not a possibility. You can only be a male or female. So we are working with u. So I'm going to put it in quotes because it's a string. So equals u. From the row side, anytime you see u, okay, comma. Now, what I've just done here is just to work for it's working for the row. You know, I said data frames are by rows and columns. So on the left side of the comma is working for the row. Now on the right side is working for the column. So I'm going to indicate the column name again, which is gender. So you can see the difference. This comma is separating them. This is the right side, which is column, which is the name of the variable I'm working with. This is the left side, which is the row, which is trying to tell us that anywhere in the row where you see gender being equals to u. Okay. So I'm now saying, okay, equate that, assign that to a missing value. It's NaN, like I said, NaN. That with a missing value anytime it says u. Let's run that first. Okay, if that runs successfully, then I'll say dat.add just to see my dat. Okay, so let's see we have, okay, let me return 10 rows. So let's see that. So you can see where we had U before, it has been replaced with a missing value. NaN is for missing values. Okay. So in case you wanted to follow from the start, this is where we started from. We imported the data, we viewed the data, and we performed these operations for subsets. And now we are at the stage where we are replacing values in our data frame with another value, which is a missing value. Okay, good. Visualizations. Let me quickly show you how to, let's say, who's raising their hand? Please ask your question. Who's going first?
Hi.
Hi.
Are we going to get the notes after? Or are you going to put it on the chat so that we can do the practice course now you fast?
Oh, okay. I'll do that. Yeah.
Please. Thank you.
I'll do that. I'll do that. Is that all? And this one?
Yes, sir. Sir, I'm asking if I'm asking 2 questions. Can you please scroll up?
Okay.
Yes, yeah, there. So as reading a file in Python, do we just write the file name in double quotations?
Like you mean this one?
No, not that one. Where we read a file.
Oh yeah.
The Excel.
Yeah. If you use this, look at this question is easy to answer. So that you see for yourself whether it's a single quote or a double quote. It doesn't matter. Can you see?
Yes, sir.
Yeah.
Can you scroll down again? Down. I was asking with the nen, yeah, from NumPy import nen. Is it the name of the value we are replacing with the U?
Yes, nan is a code or symbol for missing values in Python.
Oh, so it could be either nen, null or nen.
No, it's nan, like NaN. This is it.
Okay, no problem.
Yeah. So like if you want to find out more about that, you just type. Okay, let's say for example, I don't know. If there's a particular function you are not familiar with, and you want to know more about it, like, because we are also teaching you how to learn, not just to teach you everything in Python. So if there's a function, say, let me say that.add, just type question mark before that function. So, and try and see what it's going to show. So you see, so if you had no idea what this add function was doing, for example, you could type a question mark before it, and it will show you the details about it. Okay. As
yes,
you can
sir.
see, you have a more detailed explanation here. Okay. Let me delete that. So let's say you want to delete a particular cell, just click on this. Can you see? And that's it. So let's get back to a new cell. Oh, I did that in error.
Excuse me, sir.
Yeah, go ahead.
Does the capital letters have any implication when we are doing that? I've seen you have used the small letters on top, and here down it's capital letters for nen.
Yeah, it's small letters when you are typing it, but it returns the capital letter. Yeah, so it matters. From NumPy, from the library NumPy, it's the documentation says small letter NaN, so it matters.
Okay.
So can I ask one more question?
Yeah.
Can you show me an instance whereby we'll be asked to get information, for example, with Wales and West, whereby we have to just get a name if it has West. If it has West, I don't know if you understand.
I don't get that.
Let's say we are given an instance whereby we have to display information of people that have their names
Okay,
consist
you know
of
what?
West.
Let's do it this way. Let's do it this way. Can you please pile up your questions, okay? So that at least when I'm sure I've covered what I intended to do today, when I'm sure I've done that, and we have leftover time, then I'll start to address questions that are outside what I'm actually teaching. Can we do that?
Yes, sir.
Yebo. Thank you. Because time runs really fast. Before you know it now, and we still have to do machine learning, at least just to introduce ourselves to machine learning. I think that's the icing on the cake. I'll open a new cell, okay? And I want to show you how to create an heading, like, okay, to say this is an heading and where I can type my text. So let's say I want to say this is now, what I'll be doing now is visualizations. So this is not a Python code. It doesn't see it as a code for execution. It's just a text. So I press Alt Enter and it sees it as an heading, okay? So again, the default is code, but you could change it to heading, okay? And you could also make use of this markdown if you wanted to, if it's not an heading, but it's a text. It's not an heading, but it's a text. For example, I want to say, please bear with me. And I run that, okay? It's also a text, but it's not an heading like this, okay? So those are the two options you can play around with here. But the default is code. So under visualization, that's where you may be making use of this this library, okay? So I already imported that library. So what do we do next? There are different charts or plots you probably are familiar with. You probably are familiar with a bar chart, histogram, line chart, box plot. All of these graphs come in handy when you are running a data science to visualize your results. So it's a very essential skill. For those of you who probably had a statistics introduction class during your university days, you'd agree with me that there are different types of graphs for different categories of variables. If the variable is continuous, like age in this case, like L time, AFFL, which other one? I think those are the continuous variables. So the appropriate chart will probably be histogram, box plot, and the likes. But if it's a categorical or discrete variable like gender, categorical, the possibilities are male, female, N group, region. So yeah, you probably want to use a bar chart. So let's start with histogram. I'm going to plot an histogram for age. For age. Mind you, what did we call our pie plots, matplotlib pie plot? What did we call it? We called it PT. Okay, we called it PT. Since we called it PT, so I'll come there to say PT dots. Now, PT is the library, but inside PT, going to refer to, we are referring to histogram. So east. PT dot. So inside that, like I said, if you want to reference a particular, there are two ways in this case. You could either say that, which is the name of the variable, dot h. Okay, if you run this, you have what I have. You have a histogram. Can you see it? If you don't want to use that method, you could also say that using the square bracket approach I told you about, and type in labels h, and you get that. Okay. So two different ways. So I either say that's age or that's dot h. Okay. Either ways. So let me leave this as a comment. So yeah, so that it doesn't execute it again. So that's it. Were you able to produce this graph?
One person says yes on the chat. Okay, there's another yes.
Okay, good. So let's say, for example, you want to go ahead to do some labeling, because it's always good, like I said, you want to know more about the function. So just type pt.histogram ist to know more about the possibilities. What else can I add to this histogram? So let me seek help. So what does Python have to say? It says, using this function pt.histogram, I need x, which is the variable. I could declare the bins. I could declare a whole lot of stuff. Histogram type, do you want it to be in form of bars? If it's not bar, what are the options? So you see that here. Let me see. It says histogram bar. Do you want it to be in form of bar, or do you want to be a bar step? There are different types, but the default is bar. So you can play around with this. Do you want it to be aligned to the left, or in the middle, or to the right? The default is the middle. You could change that to left. So these are possibilities. These are possibilities. So, but let's say I want to include the labels, like say, okay, of course, the default label, okay, there's no label here. So let's say I want to include x-axis label to the age. So I'll just see .x label. I then have to tell it what I want to call it. So if I say this is age of the customers, age of customers, that's what I want it to display. So let me run that, of customers. So let's see what we have. But why I'm familiar with PLT. I don't know why I keep using PLT. It's PT, but I use PT in this case, no problem. Okay. So can you see, we now have a label, age of customers. I could do that for the y-axis too. If I wanted, I just need to change this X label to Y label. It's as simple as that. I could also include the title of the graph. So that's just pt.title, title of the graph. So what's the title of the graph? Let's see, this is age, histogram of age. Histogram of age. Histogram of age. Why am I being echoed? Okay. Okay, you can see that. So there are a lot of stuff you could do here just to customize this graph. But what's important is the keyword here, and that allows you to plot the histogram. So whatever you're adding to it is just secondary, okay? Box plot is also used for continuous variables. And not just that, you could use a box plot for a continuous variable by a categorical variable. What I mean by that is, if I wanted to plot age of customers by gender, I could use a box plot, and you see that now. So let's start with the keyword pt.boxplot. Okay. Now for box plot, it wants us to specify, because since Python was updated, this box plot function wants us to specify what exactly the labels are. So is data equals to that? Unlike, for example, I could have also said x equals that age here, for example, because if you look at the documentation, what we have here is x. So, but because this one does not have issue, the histogram does not have issue with that. But I think for box plot, it wants us to specify what exactly this is. So data that it wants us to specify the data. Okay. Now x is now where you specify the variable, just like what we have here in the histogram part. So x equals that, and reference that to say, okay, I'm plotting age. Okay. I could also plot something else. There's another variable here called AFFL. Yeah. So let me plot that AFFL and see what. So let's see. Let me see what's wrong. Let me see if it's omitting that value. Okay, let me check the documentation to see, because like I said, these skins, they keep being updated, and you have to check the documentation for the latest example. So let's see, it wants me to put x, okay, data equals to none. So this is a real life situation, what you could also encounter when you are doing a data science project. And this is what I usually do. I check the documentation to see what has changed. Because, for example, if you are using a previous version, it's possible that this same code I ran will not have an issue. But now, they probably have updated, and there's some, you need to include some parameters here, which I did not include. Okay. So, but I'll try and see what the latest, but I'll study this and see what has changed in order not to waste time. But that's the style. Like if you run into problems like this, go back to check the documentation to be sure that nothing has changed. Okay. So we've done. And that's when, in a case where you want to plot two variables and see if there's a relationship between them. And mind you, these two variables have to be continuous. Okay, you can't do a scatter plot of, say, gender and marital status. These variables are not continuous. So the only suitable set of variables that you can use for scatter plots are continuous variables. And I'll be doing that quickly with the scatter function. So that's pt.scatter. Then the variable names now is that. So let's look at the relationship. And let me see another variable here, age and bill. So let me see that.age, that.bill. You know, I told you could either use the dots to reference this variable or use this square bracket. So let's see pt.scatter that.age, that.bill. So you can see a scatter plot that suggests a positive relationship, because you can see more the observations moving towards the right. to say, okay, as age increases, the bill also increase, something like that. So scatter plot is used, or scatter plots are used for association, for describing associations between two variables. Of correlation. We've seen firsthand what a scatter plot is. It just gives us a graphical representation of the relationship. But what if I wanted to get the actual correlations? Correlation is the degree of relationship between two variables. So that means it assigns a value, a numerical value, to the degree of relationship. Yeah, I can only say, okay, between X and Y, there's a positive relationship. But what's the magnitude of this relationship? So that's where correlation comes in. So I could say, I'm interested in the correlation of variables. So I called it call. What is on the left-hand side is what I choose to call it, but the keyword is that.call. So that means, so that you not think they are the same, I'll change this to like COR, so that you know that they are different. So that.call is the keyword for correlation. And once you type that and you type call, what do we have? You have a matrix of correlations to say, okay, between age and bill, this is the correlation value, 0.259. Between age and AFFL, age and AFFL is the negative correlation, minus 0.139. Bill and L10, like, so you have the correlation values here. But how do you plot it? So there's a beautiful plot that we can use, which is the heat map, but it's under, okay, let me check the charts. Can you demonstrate the chart that deals with at least two variables? That's what I just did, the scatter plot. How do you plot a different graph? Maybe a line graph. Okay, I'll do a line graph now. What else? Thanks for the video. Okay, I'll do a line graph, but let me conclude this part first. So this is the correlation. So let's see what happens if I wanted to plot that. So I'll use there's a package or a library called Seaborn. Like I said, Seaborn was built upon Matplotlib. So there are some more sophisticated plots or graphics that you can get from Seaborn, and it does not exist in Matplotlib. So let me import Seaborn. Seaborn has more advanced graphics. So Seaborn has SNS. So let me run that. Go to the next line. Now I have SNS. So I'd say SNS dot itmap. Itmap is the name of the plot. Itmap. Now what does it want to plot? Remember, I already got the correlation, so that's what I want to plot. This COR. So I'm going to plot it COR. Okay, and you have this beautiful map. That's okay. You have this legend showing different colors representing the degree of relationship. These are the correlation values. Okay, lighter pink are close to 1, and purple colors are close to between 0 and negative. So this is it. So if you are doing a data science project, it will be nice for you to have this in your results if you are illustrating relationship between variables. So unlike this one, which is a scatter plot, this one only plots the points. It doesn't plot the correlations. Lungile.
Hi, can I record this video, this
No, it's
meeting.
been recorded already. It's been recorded.
Thank you.
Okay. So let me quickly do a line plot like as someone I've requested. So let me do that. So what's a line plot? A line plot is used for plotting a series, just a single series over time. Typical of time series, you have a data set for one variable and you have record of that variable over time. Okay, so let's see how that works. So we still have our PT as to say PT.plot. It's as simple as that. So unlike when we had PT.scatter, now this one is just PT.plot. We had PT.boxplot, we had PT.histogram, which is east, but now for line plot, it's just PT.plot of the variable. PT.plot of that dot. So I could plot a variable like L time. And you would see, yeah, so this is it. So like I said, a line plot is typically for a time series data that is indexed by time. So you have one variable over time. So if I wanted to plot the exchange rate of rand to the US dollar over time from say 2020 from year 2000 to 2020. So you have something that like this that goes up and down over the years. Do share the link for today. Okay. So that's this is by no means exhaustive. Like there's still a lot of plots, but as it requires, you get to know more of them. For any data science work, it depends on the project you are working on. You probably will say, okay, what are you feeling NA? So that's age, okay, dot mean. If I wanted to do for mean, if I wanted to do for median, I could do this. Yeah, but let's do for mean and see. Okay, so that's ran successfully. So let's see our dat and see what happened to age. So let's see our age. You can see the age has been replaced with the mean. Where we had missing values initially, if you look up, where we had missing values for age, yeah. Okay, let me open for 20. Let's see 20 rows. So I want you to see the original data, so that you could see what has been replaced. What I should have done is for you to first of all see the original data and see what has changed. But that's not what I did. So what I would do now is show you the original DATs. But that means I have to go back to getting a copy of that so that you see the old DATs and see what has changed. So let me quickly do that. So this is the old DAT. Let me run it again. So this is the old DATs, okay? And let's now see the head of that to see variables that have missing values under age. So let's see that for age. Yeah, good. So for age, under row 11, there was missing value for age. Can you see that? So let's now go and see the new DAT. What has happened to row 11? The new DAT for row 11 is now being replaced with this. Can you see? 53.743905. So that's the mean. So it replaced that missing value with the mean of age, okay? And I could change that also to median. Okay. So that's it. Let me know if you also got that. Otherwise, I'm going straight to modeling. Okay. Modeling, let me make this heading. Okay.
Okay, we're left with 45 minutes, Latif.
Yeah. And do modeling, sorted out missing value, how to deal with them. Look at these variables under that. There are some of them that are not numeric. Some of them are not numeric. So we need to change them. Otherwise, our models will not accept them as they are not numeric. Which variables am I referring to? I'm referring to gender. I'm referring to TV reg, N group, region, and class.
Sorry,
These
sir,
variables
can I
are not.
disturb you?
Yeah.
I'm just wondering, so the first time when we were removing the null values, we just removed them. And then the second time, we used the mean to just fill in those null values. So I'm wondering, when is it like the best time to remove and when is like the best time to use the mean values?
Yeah, very good question. For me, first of all, whether it's mean or median, the variable has to be continuous. That's number one. You know what continuous variables are, right?
Yes, I do.
Okay. So secondly is that you use mean when the variables do not have outliers or if the variables are not skewed. What do I mean by outliers? Because I didn't have the intention of teaching statistics. But what do I mean by outliers are variables that do not look like the others. So let's say you've got age of students and you've got age 20, 25, 18, and you've got just one person whose age is 90 in your class. That's an outlier. It doesn't look like others. So if you use mean as a measure of summary, in that case, you'll be getting erroneous results because that 90 is going to pull other values towards itself. So median is better to use in such cases because median is robust, is more robust to outliers, is more robust to skewed data. I already talked about skewed data that are skewed towards a particular direction. It's not good to use mean. So I could send you a documentation where you can read. This is theory. You could read up on these are statistics concepts.
Please, I
Unfortunately,
really do think I need that documentation, sir. So I would really like one. So yes.
Yeah. So, but that's just it basically. Mean are used when you are sure that that variable does not have outliers or they are not skewed. But to be on the safer side is better to use median. Okay, if you are not sure. Okay. So now, this is our data. I want to ensure that these variables are changed from string to numeric values. So I'm going to use the label encode function. Numeric variables or values. So let's do that. So there's a library, import, sklearn dot preprocessing. import. So it's called label encoder. I talked about sklearn, which is short for scikit-learn, which is by far the most important library I've seen so far on Python for machine learning. So it has some features like for preprocessing your data, for modeling and exploring your data. So one of them is to do labeling. So I'm going to call my label encoder, give it a short name. Okay, let me say lab encode. That's what I choose to call it. So anytime I see label encoder, that's what I want it to be referred to, label encode. So let me run that. Okay, let's see. sklearn.preprocess imports label. So lab encode equals label encoder. So let's see what is wrong. First of all, okay. See, let's check the spelling.
Sir, your mistake is that you said import instead of from sklearn.
Oh, yeah. Thank you. So it's from sklearn because that's a much bigger library. So under that, it's where you now have label encoder. So thank you. So now, let me quickly show you scikit-learn, because I said it's important you know where these things are coming from. We are teaching you how to learn. So there's this is the scikit-learn website, and everything that you need to know is there about machine learning. You can see it's called machine learning in Python. So everything you need to know about machine learning in Python. But before we go straight to the modeling, which is in our case, classification or regression, which I will explain the difference between these two terms. There are some other concepts like preprocessing. So that's what we are doing now. Preprocessing your data, that is to transform your input data, just like we are doing now. We want to change the non-numeric ones to numeric ones. Model selection is one of them. Dimensionality reduction is one of them. So, but this is what we are doing now, preprocessing. And you see the details about what we're doing. So even imputation of missing values, encoding categorical features, which I'll show you now. Standardization, there are some machine learning algorithms that require you to standardize them before you can use them. And there's a lot. So please make this your friend, this website. It's like the gold standard for machine learning in Python, scikit-learn. So, but what we are doing currently is the label encoding. So I'll go back there. So I want this to be called lab encode. Lab encode. So now, what am I going to work on? Remember, which variables am I going to change to numeric? Remember that gender, TV reg, region, class.
I'm not sure if we're losing you, Latif.
You say what?
I think we're losing you. There was this minute, like 30 seconds where we couldn't hear you.
Oh, but you can hear me now?
Now we can hear you, yes.
Okay, so what did you hear?
Like 30 seconds, like some 30 seconds or so.
Yeah, what did I say?
Disappeared again.
What was the last thing I said? So I could start from there.
The last time you were doing the import label encoder.
Label. Okay. So that's not too far. So this is just what I did. I wrote this line of code, and that I think that's all I did. To say, okay, anytime I see this, I'm referring to the label encoder. I want to change them to numeric. So don't forget, we have the data being called that, right? So that. So I'm working with gender, lab encode. Don't forget, that's what I called it here now, lab encode. And the function is fit_transform. That's the function under that library, fit_. So open the bracket, and it's going to ask you which variable are you performing down. So that's that gender. That's what I want to transform. Okay. So that ran successfully. So let's see our DAT now to see. Let's see what's in that now. So let's see, you see now the numeric values have changed, okay? They are no longer the string values. So we could do that for TVReg, region, and class. But instead of having to do that one by one, why not just do it? Why not just do it for all of them using the for statement? Remember, I told you that for statement we did yesterday is going to come in handy. You remember, right? Hello?
Yes, we can hear you.
Yeah, just want to be sure I'm still being heard.
Now I'll let you know when you go down.
Yeah,
Go
okay.
So because now you want to encode them as a totality because you just did the data column on its own.
Exactly. So that I don't have to write that code one after one, because what if you want to do that for 20 variables? So that's why we have to know how to do it using a for. So for in column names, so let's list the column names. So let's ask it to list the column names. I'm going to say column_names equals list that, okay? So that we can see the column names. Okay, so that's the column names. Can you see them? So now we are going to use these labels to replace, just like we have here, that gender. So instead of gender, we're going to replace gender with an index. So we will say for column in column names that we have defined. Okay, so that I will now replace what I have here. I'll replace it, copy and paste, to say, okay, instead of gender, now I'm not working with gender again. I'm working with because this is my index now, call, to say what's the column name. So it's going to look at, in each column names, it's going to look at customer ID, gender, age, look at them one after the other. That's the essence of the for loop. So of course, if that variable does not need transformation, it will leave it out. So I do the same for this. This is going to be call. So it's going to loop through all the variables. Who's raising their hand?
No, so I was just wondering, it seems as if you're going to encode for all your columns. Now I'm wondering, do we need to encode for all columns, even like the continuous ones, or are we just not supposed to just take care of the categorical ones? Yeah.
You know, I said the non-numeric variables. So if it sees a variable that's already numeric, it doesn't work with it. You get what I'm saying?
Oh, yes. I
it only works with the labels.
Oh, okay. Thank you very much, sir.
So this let me label and code. Okay. Dot fit underscore transform that and the name of that column names. All in column names. Okay, I didn't put
The
this.
column.
I didn't put indentation. I didn't put indentation. Yeah, that's it. Okay. So let's see our new data frame. Let's see our new data frame. That's dot add. And see, you see what I was saying? So we've got gender. Okay. Gender was, we've got TV reg has been changed to numeric, end group has been changed, region has been changed, class has been changed. Now we are good to go for our modeling. We can now go into modeling proper. So let me know if you also got this. Let me know if you also got it.
Looks good, Latif. I think we're in a good thing because we can see that it's those categorical columns that got encoded.
Okay. Okay.
Thank you.
Good. Okay. So now it's also possible to do some other transformations, like you want to scale your variables, okay? But like I said, we can always think of so many things, but because of time, I just want to go to the most important ones. But just for you to know, there are some machine learning algorithms like support vector machine, which does not work well if you don't scale the variables. So if you wanted to do an algorithm, what is it called now? The scalar function, I think standard scalar. So, but you get more details in scikit-learn website I just showed you. So let me just quickly show you an example. So let's say I define my scalar, a standard scalar. A standard scalar, what does it do? It converts that variable to have a mean of 0 and standard deviation of 1. Okay. So let's say I want to start inside my data frame, and I will just say scalar fit underscore transform, and you'd indicate something like that. So, so let's say I wanted to transform H, fit.transform of H. Okay. Okay. Let's go to model. Libraries we need to import. Well, in this class, let's fit models like regression, linear. Okay, now whether it's linear regression or logistic regression, let me do some recap. In machine learning, there's what we call supervised and unsupervised learning. What we want to do now is supervised learning because we have a target variable. What's our target variable? This guy here is our target variable. Because that's the variable we are trying to predict or trying to classify in this case. The two languages here is either classification or regression, as you can even see from the website. You can see from the scikit-learn website also, you see that if you're interested in classification, you've got algorithms that can do that. If you're interested in regression, you've got the algorithms. This is clustering. Clustering is unsupervised learning, which unfortunately is not in the scope of this class. So we are dealing with this now. Why are we dealing with this? The data we are using is a categorical variable. It's either yes or no. If you look at the options in the data, it's either yes or no for origin, 0, 1, 1, 0, yes or no. So that kind of data is when you are predicting, in that case, it's not a numeric value, so it's called classification. You classify them as yes or no. But if it's the other way around, which is regression, regression is when you are predicting a continuous variable. So for example, if we wanted to predict age, or that variable bill, these ones are continuous. So that won't be classification, it will be the right word will be prediction. Okay, having digressed, let's now come back to Python. So we are doing classification, and because of that, I'm going to import some that allows us to do classification. Logistic regression is probably the simplest. It's like the gold standard. Learn. So sklearn dot there's okay, linear underscore model. I mean, we want to import logistic regression from sklearn.linear model. So how do you spell logistic? L and capital R to separate. So if you wanted to work with decision tree, you could also import, let me just copy this from this imports decision tree. So you don't even need to memorize these things, because once you go to scikit-learn, you know what from the documentation, you know what they are doing. For example, you know I want to work with decision tree, but I don't know what is being called in my scikit-learn. So I need to go to scikit-learn to know what is being called. Okay, but because I'm already familiar with this process, you know the spelling that, okay, this is decision tree classifier. But for beginners like you, the documentation to see which one does the particular model. So let's do a support. I'm going to import SVC forests. Okay. I know a lot of machine learning algorithms exist, but once you know how to do one or two of these, it's the same thing to be changing the algorithms. Do you agree with me?
We agree, Latif. Yes, we agree.
Okay. Okay, so what's wrong now? Let's see. Cannot import
Isn't it
decision
case
tree.
sensitive on the tree, like the starting decision tree classifier?
Say what?
Yes, that's what I was suggesting, that the tree was a small letter.
Yeah, so let me see. Cannot import decision tree classifier. What's important is, if this is going to be the problem, because I can't afford the time to go and check the correct spelling, but like I said, you can always get it from scikit-learn. I can easily work with this. Let's see what's wrong. From sklearn.linear model, cannot import SVC. Okay, I'll see what's wrong now. It's this. So this does not have a problem. So what's wrong with the other two? This is strange. Oh, okay, sorry. For SVC, it's not linear model. For SVC, SVM, yeah, sklearn.svm. And for random forests, it's not ensemble. So this sklearn.ensemble. So let's do that. Yeah, so that's it. So now we have There's what we call cross-validation. There's what we call cross-validation or training and testing in machine learning. Let me quickly explain what that means. We've got 10,000 rows. It's not advisable you just plug in those 10,000 into your machine learning algorithm and ask it to do training. What you do is there are so many ways. One of them is to partition the data, maybe 70, 30%, 80, 20. Let a percentage be for training, and you have a leftover which is independent, and you can use it for testing. It's just like when you want to ask a student an exam. You set an exam for some set of students, and you already showed them the question before the exam. Like you already even showed them the marking guide. So if they pass such an exam, it's not a true test of their competence because you already showed them the marking guide. Compared to a student who you are setting an exam for, they don't have an idea what the question is beforehand. They have not seen your marking guide, and they do well in the exam. Okay, so that's the essence of training and testing. You set aside some set of data, let the algorithm do its work with the training data, and we can now confirm what it has done in the training with the held out set that was not there when you were doing the training. Does that make sense? Okay. Okay, someone wants me to run the scalar code. I'll run it just now. Partitioning of data, like I was just explaining. So in machine learning, there has to be a target variable for supervised learning. So what's the target variable is the origin variable. So I will extract it. So I have to tell the machine, I have to tell it which one is the target variable. Input variables. The other variables are called input variables. So I'm going to say, let me start with X. Let me call it X. X is for input. So I'm going to say that dot drop. That's the function. So I'm going to drop for origin. So that dot drop origin. And I'm dropping from the column. So I'm saying axis equals to 1. If it's axis equal to 0, it might probably tamper with row selection. So it's better to use axis equal to 1. So let me run that dot drop origin, axis equal to 1. So what this is saying is that extract X for me. Inside X, let it be every other variables, but not origin. That's the meaning of that dot drop. I'm dropping origin, but I'm leaving the remainder. So, and of course, to get the target variable, we call that Y. Y in machine learning parlance, we call it Y. So Y is that dot, now, what's the name of the variable? Origin. So that means it's only going to retain origin. So you can see the difference. The first one was saying drop the origin, but this one says retain only origin. So you can see. So we now have X and Y. So X alone, let's see X alone. You can see X alone has all the variables except Y. You can see Y alone, and this is Y alone, okay? Just the target variable. Now that we've done that, let's go and do our splitting of variables into training and testing. If you want to know more about splitting the data, the websites,
we're losing
so let's
you.
do that.
We're losing you when you're referring to the website where they can check the splitting of data.
Yeah. So So that is you can find it here. Cross validation. You'd see it somewhere here. Yeah, this is it. Can you see it? Can you hear me?
I hear you. You're on the we can see.
Yeah,
Yes.
so this is one I'm using right now, this train test split. But I'm saying this is not the only option available. There's the cross validation score, there's the shuffle split, there is the k-fold, leave one out, okay? But like I said, we can't do all of them. Let's just do one of them. But this documentation is there for you to play around with. So I'm doing this right now. So I'm just going to type this. Let me just copy it. So I'm going to split the data into training and testing for both the X and the Y. That's what I'm doing now. And this random state, what it's going to do is to say, if I want for reproducibility, so that the same value that I get, you also get. But if I don't put this random state, we could get different results because it's selecting them randomly. The test side is 40%, so it's selecting 40% randomly. But if I put random state equals 0, for example, if you use a random state of 0 also, we'll get the same results. So that's that. So let me just copy it and come back here. So I'm splitting X and Y into training and testing, okay? But I don't want to use 40%. I want to use 70-30. So let me make this 0.3 so that the training set will be 70% and the test set will be 30%. So let's see. Yeah, this is not going to run because I've not called the library for train test splits. So let's go and do that. Import. So there's the library. So I think it's just import train underscore test underscore splits. Okay, that's what I want to import. But where am I importing it from? So it's from sklearn. It's from sklearn dot model selection. Okay, model selection. So now let's see. Good. So we now have a new split. So let's see what's in the splits. So X train, for example, is where you have all the X in the training data. So let's see the shape. You can see X train dot shape. So you see 7,000, which corresponds to 70%. So, and you have 12 input variables. Let's say X test dot shape, which is the 30%. You can see that's 3,000 left over, and you still have 12 input variables. So that's it. Xtrain dot shape. Yeah. So that's it. Now we have the split. The variables. In the scaling, because we have missing values, which I have not dealt with, we might have issues. So let me quickly run the missing value code. Even though there's a in scikit-learn, there's the input. Permit, but if I can. Okay, let me do this. Since this is just for illustration, let's go back to where we had the missing values being imputed. Yeah, that dot drop any. Let me work with this. So I'm going to drop all the missing values inside my. As a matter of fact, I should have done this before splitting. So let me do that for X first. I drop all the missing values in X. Okay. So now that I've dropped all the missing values, let me run this one so that the splitting can be affected. So let me run this again. Okay, so that's it. And I have a new data set or data frame that do not have missing values. So let's view X. So you can see our X no longer have missing values. Okay. What else? Let's start with logistic regression. Let's start with logistic regression. Yeah. Have you heard of logistic regression, please? Raise up your hand in the chat box. If it needs some. Let's see what we have. Yes, no. Just 2 people. Okay. Okay, yes. Okay, good. So logistic regression is just one of the machine learning algorithms that we can use to classify target variables that are non-numeric, like we have in this case. It's by far the simplest. And that's why studies, even if you build a powerful or sophisticated algorithm, you still want to compare it with the logistic. A classifier will be good if it does well and even better than a logistic. So let me define that as LREG. LREG equals classifier is logistic regression. Take note of the capital, uppercase. So LREG is that. I'm going to say LREG.fit. I'm fitting the model now. Now, if you're not sure about how this works, you can always check using question mark to see more about this. Okay, so you can see what it requires us. So it wants us to input X and Y. So what's our X in this case is the training data for X, and what's our Y in this case is the training data for Y. So that's what I'm going to do. So LREG.fit X train, comma, Y train, the training data, okay? So because of some, I don't know, transformations that ought to be done, it ran successfully, but it had issues with convergence. So, but like I said, these algorithms require some pre-processing, which probably we have not covered. So that's why this is probably giving us that issue of convergence. So what we are going to do now is, I'll go back. I'll go back to our X train and Y train to see what's in there. And if possible, we remove problematic variables. So, okay, yeah, I see what's happening now. We need to remove ID. Customer ID is not a variable that should be predicted. And we need to remove dates. We don't need these 2 variables for prediction. So I'm going to quickly remove them. So I'm opening a new cell from here. So let's remove. So I'm going to say our new X equals that.drop. So let me drop those guys. The first one is customer ID and date. How is the date spelled? Where is it now? LCD. LCD. So I'm going to drop them. Customer ID, what was the spelling? cost ID, okay. That the drop, the customer ID. Let me use this of this. Not the drop that. Let me see the message. Because it's probably not spelled that way. Okay, what I'll do for now is let's view X. X. Oh, it's X. I'm not supposed to use that anymore. X equals to X dot drop. Okay. See what's happening now.
We lost you.
Yeah.
We lost you.
Okay, sorry.
No, now you're back.
Yeah. Okay, so I was trying to drop the variable just like I did here. So what I'll do now is from here, I've got this, sorry, this, axis equals to 1 is missing, okay. Let me do this. So let me drop customer ID. Let's see, that the drop, X the drop. Yeah, so I've dropped it now. So I do the same for LC dates. LC dates, yeah. It has a problem with LC date. I don't know, but I've dropped this now. Okay. Okay, so I've dropped customer ID. So I asked it to drop this. Yeah, so now I've dropped the two of them. So let me come back here. Let me come back here and run this. Okay, the splitting into training and testing. Okay. So I'm going to move this cell up. I move it up. It should come before this. So now I can then run my logistic regression. Yeah. Okay. So guys, I'll try and see what's wrong here. The logistic regression has problems with convergence. I'll run the second model to see if it's peculiar to the logistic regression. Let me go to the next one, which is realize. So let's do for okay. DRF. Random forest classifier. Random forest classifier. Okay. So what I'll just tell it the number of trays. Let's say I want to go just on, because random forest is an ensemble. Okay, so I'll say rf.fit. And also this time around, X tray, comma Y. Okay. Now, mind you, what I did here is just to include the number of trees. There are some other options that I could include, okay? But because of time, I'll just do the what's it called now? The default. I'll work with the default by just changing the number of trees, okay? So let's see what happens now. I've called the random forest class. So I've said RF equals random forest. Then rf.fit x train, y train. So let's run that. That ran without any issue. Okay. Let me now go to the next line. So I'd say prediction equals rf dot predict. So I said we left out some data. We want to use it for confirming our predictions. Okay, so let's see. So it has done that. Report. So that it's going to report the performance of this model in terms of the sensitivity, accuracy, specificity. All these metrics suggest that the higher these values, the better the model. Like how accurate are the predictions. So import a library called import a library. From sklearn first. So from sklearn underscore metrics import. So let it import things like confusion matrix. You'd see how a confusion matrix looks like. Time will not permit me to explain it, but you see how it looks like. And then classification ports. Okay. So let's see that. From sklearn.metrics, confusion underscore matrix underscore reports.
Shouldn't there be a comma between the two? Between confusion matrix and
oh, okay, yeah.
report.
Yeah, thank you. Okay, so now I can go ahead to report my. I'll say print classification reports, print classification underscore. For what? Y test, the Y that we set aside for the test data, we want to now compare it with our predicted data. So what this is doing is saying, this is the prediction and this is the actual variable. Let's now compare them together. And that's what will give us an idea of how good the models are performing. So let's run that. Y test not defined. Okay, what did I call it? I think Y underscore tests. Y underscore tests. Okay, so this is the icing on the cake. Like, even if we don't move further than this, I'll be happy. So yeah, you've got these metrics, but like I said, because we had some values we needed to pre-process, but because of time we couldn't pre-process them. That's why we are having these funny values. But this is what it will look like if we did the pre-processing. We will get values that are close to 1, not necessarily 1. Recall values. But what's important to note here is that you have precision, you have recall, F1 score. These are metrics. These metrics suggest that the machine learning algorithm is doing a good job at predicting or classifying in this case. So the higher these values, the better. The higher these values, the better. Okay. So, but because of time, there are still so many things I could have talked about. Because of time, let me just quickly show you what a confusion. Just say very quickly, confusion matrix, confusion under that same y underscore tests and the prediction. So what this is going to do is to say, you have this matrix that says this is the correct prediction for the zeros. So this is the correct predictions for the ones. You know, the target variable has two values, 0 and 1. So this is saying it's classified correctly, these ones, the zeros, and it's classified correctly the ones. This is saying these ones are the misclassifications. Like these ones were the wrong classifications, and these are the correct classifications over time. So I hope I could explain it better than that, but I can't because of time. But that's how it works. Basically, you can run so many other machine learning algorithms. Please feel free to use this scikit-learn. There are so many other algorithms, and there are so many other pre-processing under this section that we have not done. And I guess that's why we were having funny results. But what I was interested in is to show you how to do it, not necessarily getting good results. So you could do some pre-processing by coming here. It's easy to use. Python is so easy to use that once you know how to do A, you'll be able to do B. So, but finally is model deployment, which is optional, but you know, those of you that are in industry, let's say you built this very good model, you want to deploy it to use for using.
We lost you.
Oh, when was that?
You were talking about the deployment. If you're in industry and you want to deploy, I suppose that's the last thing, because I think we're given up to 6:10 and we're at 5:00. So you're saying if you're in industry and you want to deploy, this is what you should do.
Yeah, if you're in industry, I'll send you 2 links. We have a tutorial on how to do deployment. Like after you build all these models, how do you deploy it for usage? So I'm going to send you the links now. Okay.
Can you also please send us this tutorial as well so that you can practice?
Okay, I'll save it now and send it on the chat. I mean, to your emails rather. I'll send it to your emails. Okay, but this, if you look at this tutorial, it's an excellent tutorial on Python Flask. Flask is used for model deployments. Like all these models you are building. Let me show you an example of a model that has been deployed. This is one of them. I'll show you now. This is the link. These people, what they did was to build a classification model that classifies a question as being genuine or not genuine. I'll show you how it works now. Is it popping up something? Questionclassification.com.
Yes.
Why is it taking time? Did you manage to get through this website? I think it's slow. Okay. Yeah. So this is how a deployed model looks like. Like you don't get to see what's going on the background, like all the machine learning codes, but you just have something that is user friendly like this, that people can then, work with your models, the one that you have already built. So for example, what these guys did was to develop a classification model that determines if a question that you have asked is insincere or genuine. Does that make sense? So let me ask a random question. Am I still on?
Yeah, we are with you.
Okay, who is the president of South Africa? So let's see how this machine learning model detects if this question is genuine or not. So what does it say? It says, yes, this is a genuine question. So this is what the users can relate with. But on the background, there's been a lot of Python codes machine learning codes, algorithms being developed, but deployment is when you can now make use of it as a novice or as a user, someone who is not having that technical background. Okay, so let me ask a very useless question. Why do terrorists kill? Is this a useless question? What is wrong? Oh, it says it's genuine. Okay, I couldn't come up with a useless question. Sorry. So, but that's how it works.
On the terrorist one, it said it's not a genuine question. We checked.
Oh, okay. So what was the question again?
The one where you said, why do terrorists kill? I checked for it, and it says, no, it's not a genuine question.
Okay. Yeah. So you can see that the machine learning model that they have deployed. Huh?
Yes, the terrorist one, it says that is not a genuine question.
Oh, okay. So that's just a typical example of what you would see from if you are working in the industry, this is something you should look forward to. After you have done the hard work of building a data product, try and, as much as possible, to deploy them so that people can see them. So that's the interface between the technical guys and the an average user. So that's it, guys. I wish I could do more, but time won't permit. Thank you for staying to the end, and I wish you the very best.
Have a nice day, sir.
Please don't forget to send us the recording.
I think
Yeah, so
I would like to come for this extra classes. I really enjoyed this.
Yeah, thank you.
I enjoy coding classes. Thank you, sir. It's our pleasure.
Thank you.
Thank you, Dr. Latif. That was awesome.
Thank you. So I'll try as much as possible to compile these codes and send it to Mrs. Msweli or Madam V, so that they can send it to all your emails. I don't have all your emails, and I'm sure they'll also send you the video, the recording. Okay.
Thank
So,
you,
sir,
that would be much appreciated. Thank you.
So any final words, Prof. Sana?
Thank you, Dr. Latif. As you can see, I really enjoy your classes. I stayed until the end, despite this busy schedule. And from the comments of the participants, clearly a lot of skills have been imparted. In fact, I'll probably like one or two people to just give us feedback where they came from, especially those who started from nothing and now they have a good idea of what Python is all about. But we really appreciate your efforts, Dr. Latif. We don't take it for granted.
Thank you.
So, sir, can we get videos of your tutorials?
Say that again.
So, can we get videos of your tutorials?
Do I have videos?
Yes.
No, the videos will be shared. Usually, Nkosikona sends them it takes a few minutes to compile. And then Nkosikona will send them to all the participants. She'll send you a link while we create them properly for the Nemisa website, YouTube channel.
Thank you, sir. It's our greatest pleasure.
On a final note,
before you leave, Doctor.
Huh?
Before you leave, Doctor, how can it get hold of you?